Helping Learn, inspiring minds, building futures. Explore the foundational concepts of Java programming that empower robust and scalable software development. Navigating Java's abstraction, interfaces versus abstract classes. In Java, both interfaces and abstract classes are crucial for achieving abstraction, enabling flexible and extensible code designs. Understanding their distinct roles and appropriate use cases is key to mastering object-oriented programming in Java. 1. 2. Interfaces. Abstract classes. Define contracts for behavior. Provide partial implementations for related classes. Deep dive. Java interfaces. Syntax and implementation. Behavioral contract. Multiple inheritance. Interfaces are blueprints for defining shared behaviors that multiple classes can implement. They specify what a class must do, not how it does it. Declared with interface keyword. Classes use implements to adopt its methods. Example. Interface drawable, void draw. Unlike classes, Java supports multiple inheritance through interfaces, allowing a class to implement several interface types, combining diverse functionalities. Interface details and nuances. Interfaces are designed for full abstraction, ensuring that any class implementing them adheres to a strict contract. Methods. All methods are implicitly public and abstract, before Java 8. Since Java 8, default and static methods can have implementations. Variables. All variables declared inside an interface are implicitly public, static, and final, constants. This strictness makes interfaces ideal for defining APIs and enforcing common behaviors across disparate parts of an application. Deep dive. Java abstract classes. Base for related classes. Syntax and usage. Partial implementation. Abstract classes serve as foundational blueprints for closely related classes, providing common functionalities while enforcing specific methods to be implemented by subclasses. Declared with the abstract keyword. Cannot be instantiated directly. Subclasses use extends and must override abstract methods. They can contain both abstract methods, without implementation, and concrete methods, with implementation, allowing for code sharing. Abstract class capabilities. Abstract classes offer flexibility for defining a general type while deferring specific implementations to subclasses. Methods. Can have any access modifier, public, protected, private, for their methods. Constructors. Unlike interfaces, abstract classes can define constructors, which are invoked by their subclasses. Variables. Can include both instance variables, non-final, and static variables. This makes them powerful for creating frameworks where certain core behaviors are defined, but others are left to specialized subclasses. Multiple inheritance in Java. The interface advantage. Java deliberately avoids multiple inheritance with classes to prevent complexities like the diamond problem. However, it embraces multiple inheritance through interfaces, providing a flexible alternative without the ambiguities. Classes. Interfaces. Hybrid approach. Single inheritance only, to maintain clarity and avoid method collision issues. Support multiple inheritance of type, allowing classes to implement many contracts. Abstract classes can implement interfaces, offering a way to provide partial implementations for common behaviors. Interfaces versus abstract classes. A comparative view. Aspect. Interface. Abstract class. Method types. Abstract, default, static. Abstract and concrete. Multiple inheritance. Supported, not supported. Variables. Implicitly public static final. Instance. Static, final, non-final. Constructors. No, yes. Access modifiers. Implicitly public. Any, public, protected, private. This table summarizes the core distinctions, guiding you to choose the right abstraction for your design needs. When to use each. Interfaces. Abstract classes. Use when defining a contract or a capability that unrelated classes can implement, regardless of their position in the class hierarchy. Ideal for defining common behaviors like runnable or comparable. Apply when you have closely related classes that share common code and behaviors, but also require some methods to be implemented uniquely by each subclass. Perfect for base classes like vehicle or animal. Choosing between them depends on the relationship and reusability requirements of your classes. Key takeaways and future horizons. Interfaces for contracts, abstract classes for shared code. Multiple inheritance via interfaces. Evolving abstraction 1, 2, 3. With Java 8's default and static methods in interfaces, the lines have blurred, but their core purposes remain distinct and powerful. Leverage interfaces to achieve the benefits of multiple inheritance in Java without the class-based complexities. Interfaces define capabilities for diverse classes, while abstract classes provide a common foundation for related ones. For more insights and to connect with us, visit helpinglearn.lovetoblog.com or email helpinglearn1@gmail.com.